When I start out the electrostatic notes, I really focus on my students participating in this activity because a lot of the topics and concepts that we're going to talk about in the beginning parts of the notes, they already read about in the jigsaw, so there are multiple students that read the same thing in the previous class. So I start out with talking about what is electrostatics in general, and moving on to focusing on what is electric charge, because you're studying electric charge at rest. So we talk about how it's a property responsible for attraction and repulsion, and something really important about it is that it's conserved. And so then we talk about back to like how we heard energy was conserved, and in chemistry class they hear about how mass is conserved. So what does that mean? It's not created or destroyed, the total charge stays the same, and it's transferred. Then we go to something that all my students should know, that there's two types of charge, positive and negative. And then we look at the two main things, that like charges repel and opposite charges attract. And that's something that they've known for quite some time now. So, and it was also in the jigsaw reading, so it was there as well. Then I move on to talking about the relationship between protons and electrons. So one thing is that they have different masses. So I bring that out in that first section here. Then we talk about how they have the same amount of charge, but their charges are in the opposite direction. So if you can see here, they have the same amount of charge, 1.6 times 10 to the negative 19 coulombs, but one is positive, the proton, and one is negative. Finally, we end this page with remembering that most of the matter that we encounter is electrically neutral. And so what does that mean? It means that they have the same number of electrons and the same number of protons. And that's going to be important for the next example that we look at. In this example, this is a picture of me that I draw, and then this is a picture of a balloon. And so at first I asked my students, what is the overall charge on each of these? And we say that they are both neutral. So what does that mean about the number of protons and electrons? They have to be equal. So if I have 100 protons, I have 100 electrons. If I have 50 protons, I have 50 electrons. Then I take the balloon, actually in my class, and I rub it on my hair. And so I tell my students that when I rub the balloon on my hair, it's transferring electrons from my hair to the balloon, giving it a net negative charge. So then I ask them, what is moving? It's only the electrons that are moving. So if electrons are moving, I have 50 let's say I pick 50 electrons that moved over to this balloon. That means I lost 50 electrons on this side, and I gain 50 electrons on this side. That's where we talk about our charge being conserved. So this is a general example to help my students see what happens when charge is transferred, talking about the different properties of protons and electrons, that electrons only move, and that charge is always conserved.